Welcome to the second set of 3.7 notes. Now we're going to look at applying Cramer's rule. And you might think, well, who really cares? But this is kind of easy, and it makes work on other problems quicker. So here's what Cramer's rule is used for. First of all, you have to have systems of equations. And if you think back to the beginning of the chapter or last semester, we learned we could graph them. We learned we could do substitution. We learned we could do elimination. Okay, well, here's another way to solve them. And it's going to be with matrices. Now, the one thing you have to do is you've got to decide what your coefficient matrix is. Think about what coefficients are. They're the numbers in front, so that's going to be A, that's with the first x, B, that's with the y in the same equation, C, that's with the x, and D, that's with the y. That's called the coefficient matrix, and we're going to use that in our problem. Okay, so you got that. Now remember, determinant of A, that's just the diagonal thing, so we'll find out what that number is. And we're also going to do a determinant for x. Notice we need E and F, the numbers by themselves, and we need B and D, what's with the y, and that gives us the x. If you look over at y, you take the numbers that are with the x, you take the E and F, and you make a determinant. And so we're going to find this, okay? Now you might go, oh, I don't really know. Couple things. Your determinant of A, your coefficient determinant, can't be 0. Because remember, we can't divide by 0. And this works for the kind of system that has one solution. So hopefully you can remember, what does that say about the two lines? Yes, you're right, they cross in one spot. So if you had parallel lines, or it was the exact same line, this method doesn't work. But since most of the time it's a one solution, this makes things easy. So let's come over here and we'll try an example. The first thing that we need to come up with is, what is our coefficient matrix? So remember, those are the numbers in front. So we've got a 6, and we've got a -2. Remember, your signs are really important. We've got a -3, and we've got a 5. Okay, so that's our coefficient matrix. Now what we need to do is figure out what the determinant of A is. Okay, same numbers, same order. We're just going to do stuff with them. So you do 6 times 5, which is 30. And then you've got -6 times -2, which is 6. Maybe we should put this up top. 6 times 5 and -3 times -2. We subtract between them and we get 24. Kind of a weird number, but we'll go with it. Okay, so our determinant of A is 24. So now we're going to take that second part that says x. We can find x by taking the determinant of EF, BD, and dividing it by the determinant of A. Okay, well, let's plug our numbers in. Remember, EF are your solutions. So we've got 16 and 16. And then our B was -2. And our D was 5. Okay, the ones that are with the Y's. And then we're going to divide that by 24. Okay? Well, let's see. 16 times 5. 16 times 5, that's 80. And then you have 16 times -2, which is -32. And what do you do between these numbers? You subtract. So you get 80 minus, get rid of this, 80 minus a -32, that's like adding it. So you get 112 over 24. I think something's, oh, see, now this is where you mess up. Notice this is -16. Oh, bummer. So this makes it -16 times 5. And this makes it -30 plus 32. Okay, and that's much better because I remembered what the answer was supposed to be. So this is -48. And what is -48 divided by 24? Oh, we find out x has to be -2. Sweet! And you're done with that one. Okay? Now for y, Really similar process, only it tells us to use A and C. So that's 6 and negative 3. And then our E and F. And remember, E is negative 16. Do you see how important signs are? And F is positive 16. And we're still going to divide that by our determinant of A. Okay? So I think we're going to come down here. Let's label this so when you're looking at your notes it's a little easier. This was all your X work. And now we're going to do our Y work. Okay? So Y is 6, negative 3, negative 16, 16. And what was the determinant of A? It is 24. So here we go. 6 times 16, well, that gives us 96. And negative 3 times negative 16 gives us a positive 48. Okay? And we subtract between 96 and 48. You get 48 divided by 24. Well, that equals 2. So now you know Y equals 2. In other words, the solution to this is negative 2, 2. If we went and graphed these lines, we'd be able to see that they cross at negative 2, 2. Let's try one more example, just because there are a lot of steps and you just need to be careful, and especially since I screwed up at first, it'd be nice if I would do it totally right the whole way through. So, start out with your coefficient matrix, which is just all the numbers in front. Don't lose any signs, okay? When you take the determinant, same numbers again, remember? You're just going to cross multiply. 3 times 5, which is 15, 2 times negative 4, which is negative 8, and 15 minus a negative 8 is 23. And so you might go, oh, that looks like it's going to be awful. Well, let's wait and see. It might not be so bad. Okay, so to find x, we're going to set up, and remember E and F, so negative 15 and positive 13, and then we need B and D, the stuff that's with the y's. So we've got that, and we're going to divide it by 23. Okay, so negative 15 times 5, that's negative 75. And then you've got negative 13 times, 13 times negative 4, which gives you 52. And that's negative 52. So when you subtract between them, don't forget to do that, you get, let's see, oh, check this out. You get negative 23. And I told you wouldn't have a messy fraction. Negative divided by a positive is just negative 1. So x is negative 1. Y, we set up that other one where you start out with A and C, the ones with the x's, so 3 and 2. And then you use E and F, so negative 15 and 13. And you're still going to divide by that determinant, 23. So 3 times 13 is 39. And then you've got 2, sorry, that's not a negative, I just scratched the board. 2 times negative 15 is negative 30. And what do you do between these? You subtract. We still have it over 23, don't forget that part. So this becomes 69 over 23. Oh, cool! It's 3. And you get negative 1, 3 is your x and y. So these lines would actually cross at negative 1, 3. If we somehow got rid of our y's, we'd find out x would equal negative 1. Plug it back in, you get 3. So here's an easy way to solve systems of equations. We'll be practicing soon. Bye.